Welcome back again. Let us see some more problems on trigonometry. Of successive differentiation. Okay. So okay, let me do that as of now. So I have another problem. Let us look into that. Okay. Suppose if I have sine cube x, let us find the nth derivative of this. So how do you find it? Okay. Let us find the nth derivative of this. Okay. Let us find the nth derivative of this. How to solve this problem? So how do we solve this problem? Okay. Uh, Now sine cube x can be written as 1 by 4 times that of 3 sine x minus sine 3x. Okay. This can be written like this. Okay, let us find the nth derivative of this. So I'll be having 3 by 4 nth derivative of sine x minus 1 by 4 nth derivative of sine 3x. Okay, so this would be 3 by 4 of that of sine of x minus x plus n pi by 2. Okay, minus this would be 3 to the power of n divided by 4. So this will be 3x. Okay, this will be 3x plus n pi by 2. Okay, so this will be solution for the nth derivative of sine cube. Okay, so let us see one more problem. Okay, so how do we solve that? So let's find the nth derivative of sine square nth derivative of sine square x cos cube x. Cos cube x. Let us find the nth derivative of this now. Now sine square x can be written as 1 by 2 that of 1 minus cos 2x, and cos cube x can be written as 1 by 4 times that of cos 3x and 3 cos x. Cos 3x and 3 cos x. Okay, so let us put this and simplify it completely. So I get 1 by 8 times that of cos 3x plus 3 cos x minus cos 2x. Okay, and cos 3x minus 3 cos 2x, 3 cos 2x and I'll have cos x. Okay, that's what I get. Fine. Now further, if I try to simplify it, let us keep these two like that, cos 3x and 3 cos x, keeping that like that, and I'll have 1 by 2 times that of cos 5x and plus cos x minus 3 by 2 times that of cos 3x and cos 4x, cos x, cos 3x, cos x. So this results to 1 by 16 times that of, if I try to simplify it further, I get 2 cos x minus cos 3x minus cos 5x. Fine. Let us find the nth derivative for this. So nth derivative of this. So this is 1 by 16 of nth derivative of this. Let us find this now. So for cos, the nth derivative will be, this is 1 by 16 of 2 times of cos x plus n pi by 2, okay, minus 3 to the power of n, okay, this will be 3 to the power of n cos of 3x plus, this will be n pi by 2 plus 5 to the power of n, this will be minus, we take minus outside, minus cos of 5x plus n pi by 2. So what we have done is, for nth derivative of sine square x, cos cube of x, so I get this result. Okay, let us try to solve another problem. Okay, so nth derivative of the function if I have, okay, suppose if I have nth derivative of cos x into cos 2x into cos 3x. Let us find the nth derivative of this. Let us keep cos x like that, okay, and cos 2x, cos 3x, I can write this as half of cos 5x plus cos 3x, okay. Again, if I multiply this throughout, so I get 1 by 2 cos x cos 5x, okay. So this will be x, okay. This is half of cos square x. Now this further, if I try to simplify, so I get 1 by 4 times of cos 6x plus cos 4x. Fine, this is done. And I'll have 1 by 4 times that of cos 2x plus 1. Okay, now let us find the nth derivative of this. So I'll have 1 by 4. For this, nth derivative would be 6 to the power of n cos of, now 6x, so you'll have 6x plus n pi by 2. Okay, and for this I'll have 4 to the power of n, okay, cos of 4x plus n pi by 2. Okay, plus, since 1 by 4 is common for all, I'll have 2 to the power of n cos 2x plus n pi by 2. So that is the solution for the nth derivative of this. Okay, let us find another problem, how to solve the nth derivative. Okay, and please send me a mail. Okay, and you can watch this video again and again. Okay, so let us find the nth derivative of e to the power of minus x sine square. Now let us find the nth derivative of this. Okay, so the sine square can be written as 1 by 2 times of that of 1 minus cos 2x. So let us write that. So this will be, if I take half, okay, half of nth derivative of e to the power of minus x. Okay, so sine square I have told 1 minus cos 2x. So 1 minus cos 2x plus. Now first let us find what is nth derivative of e to the power of minus x. So let us write that half. Now nth derivative of that would be um, minus 1 to the power of n e to the power of minus x. So this is the nth derivative of this. And minus of, this is half, keep it closed. Now this is in the form of e to the power of x. See, we have e to the power of x and cos uh, e to the power of ax and cos bx. So let us substitute that. So I'll get as 5 to the power of n by 2, okay, e to the power of minus x outside, and cos of, I get 2x plus n times that of tan inverse minus 2. So this is the result which I get. So 5 to the power of n by 2 e to the power of minus x cos of 2x plus n times that of tan inverse minus 2. So let us write this. Okay, so we have e to the power of x common throughout, so I can take e to the power of minus x outside. So I'll be having minus 1 to the power of n, okay, and this will be 5 to the power of n by 2 and cos of 2x plus n tan inverse minus 2. So this will be the nth derivative. Let us try to find the next problem and nth derivative of this. Okay. Okay. Try to solve more and more problems on this. and it keeps on uh, interest. Okay, you get the interest on that. Okay, let us try to solve the problems on by using Leibniz theorem. Okay, let us find the nth derivative of suppose if I have x sine 3x. Let us try to solve this problem. Okay, and how to solve this problem by using Leibniz theorem. Take u as x and v as sine 3x. Okay, so if you find the derivative of this, so if I consider this as u1, so this results to 1. If I find the next derivative of this, this would be 0. Again, u3, that will be 0, and so on. Okay. Now, if I consider this v, and if I consider this, so nth derivative of this would be 3 to the power of n sine of 3x plus n pi by 2. So this will be the nth derivative of this. So here you can consider up to u1, and the next terms will be going to 0. So let us find that. So if you consider that as u of vn, u of vn, let us try to solve this. Now this will be u vn plus n c1, okay, u1 and vn minus 1, okay, and the rest terms will be 0. Okay, so I'll have, this is x, okay, 3 to the power of n, fine, and this is sine of 3x plus n pi by 2. So done. Now nc1, which is n, okay, into, now u1 being 1 into, okay, now this will be 3 to the power of n minus 1 sine of 3x plus n minus 1 pi by 2. Okay, so again, if I try to simplify further, 3 to the power of n minus 1, okay, I'll have 3x and sine of 3x plus n pi by 2 plus n times sine of 3x plus n minus 1 pi by 2. So this will be the solution. Okay, I hope you understood this. So let me try to solve another problem on this. Okay, so suppose if I have the nth, I have another which is x square. Let's try to find that. And log x square of log 5x. Let us find the nth derivative of this. Okay. Now how do we solve this? Again, consider u as x square and v as a log 5x. Okay, so u1 will be 2x and u2 will be 2 and u3 will be 0. Okay, 3 will be 0. So as u4 and so on. Now what would be for this? So this is Vn is minus 1 to the power of n minus 1 into n minus 1 factorial, okay, into 5 to the power of n divided by you have 5x to the power of n. Okay, so this is Vn. Let us write the nth derivative of this. So if you consider u, v, n, okay, so this would be u vn plus nc1, okay, u1 vn minus 1, okay, plus nc2. This would be u2 vn minus 2, and the next terms which is 0. Fine. So let us try to evaluate this. So you get u as x square, vn being minus 1 to the power of n minus 1 and n minus 1 factorial 5 to the power of n divided by 5x to the power of n. Okay, if you try to simplify further, I get this phi n gets cancelled. Okay, so I'll be having in the denominator, okay, if I try to simplify, I'll have x power n, and this will be nc1, which is n, and this is 2x, and vn minus 1, if I substitute this, so I get minus 1 to the power of n minus 2, okay, and n minus 2 factorial divided by, I get x to the power of n minus 1. And we have one more factor, which is n into n minus 1 divided by 2 factorial. Okay, so this would the 2, and this is minus 1 to the power of n minus 3. This is n minus 3 factorial divided by x to the power of n minus, this will be n minus 2. Further, if I take common, okay, the common factors here, what we see is n minus 1, 1 to the power of n minus 1, and x to the power of n minus 1, or if I take 2, okay. So here I'll be having n minus 1 factorial, okay, minus 2n, okay, into n minus 2 factorial, fine, and plus n into n minus 1 and n minus 3 factorial. So this will be the solution. Okay. So let us see one more example. Suppose if I have to find the nth derivative of x cube and a power mx, let us try to solve this. It is x cube a power mx. Let us try to find the nth derivative of this. Again, consider u as x cube and v as a to the power of mx. So you will have u1 as 3x square u2 as 6x and u3 as 6. Now Vn will be, now this will be m log a, m log a, and to the power of n, a to the power of mx. So this will be your Vn. Okay. So let us find uv n, nth derivative of this. Let us find this. Now that is u vn plus nc1, okay, u1 vn minus 1, right? Now nc1, so that can be written as, so that can be written as nc2. So let us put that also. So this is nc2. Okay, so this will be u2 vn minus 2, and again we have nc3 u3 vn minus 3, and the next term would be 0 plus 0. Now u being x cube, let us put that x cube, and this would be m log a to the power of n into a power mx. Okay, so this will be n, and this will be 3x square, 3x square m log a to the power of n minus 1. Okay, so a power mx plus nc2 will be n into n minus 1 divided by 2 factorial. Okay, n into n minus 1 into, but divided by 2 factorial into 6x. Now this would be m log a to the power of n minus 2 into a power mx, right? And plus we'll have n into n minus 1, n minus 2 divided by 3 factorial, okay, into 6. So this would be m log a to the power of n minus 3 a power mx. Okay, so when you try to take common, okay, if I take common, so those are m log a, and if I take n minus 2, m minus 3, as well as if I have a power mx is common, okay, so that is also common here. So I'll get x cubed, okay, so this will be x, sorry, m log a, the first term we will have as cube, okay, so I'll get back the same function, and this 3n x square, okay, this will be m log a whole square, okay, and plus we'll have 3 into n minus 1, so x into log, and this is m log a, okay, and the last term I'll be having, okay, here this gets cancelled. So and I'll be left only with n into n minus 1, n minus 2. So that will be the solution. Okay. I hope you understood this. Okay. Let me try to solve another problem. Okay. So let us see how it goes. Okay. Suppose if I have a problem of this type, that is, you have as x square and so on. Let us see that how to solve that problem. Okay. You want me to repeat? Okay. Um, yeah, you can send me a mail. Okay. Which all you didn't understand. Okay. So wherever I've done mistakes. Okay. So you want me to repeat that? Okay. If I conclude the last thing which I said. Okay. Uh, that is if I have as suppose if I have taken m log a and which is common for n minus 3 which is outside and a power mx, okay, which is common. So I'll be left with only the term which is x cube, okay, and m log a, and that is cube, okay. Okay, thank you. Now, I hope you understood, right? If you have any queries, you can send me this. I can send you to your email later if you can provide me your email address. Okay, okay. I can try to solve this and send it to you back again. Okay. Let us try to solve another problem. Suppose if I have to find uh, x square into e to the power of x cos x, okay, d to the power of n. Let us try to solve this problem. Okay, so now again you have to separate that. Here if you look at this, you have u as x square, okay, and v as e to the power of x cos x, okay. You have two entities here. Okay. Now again, let us find what is u1. U1 will be 2x, okay, and u2 will be uh, 2, okay. So u3 and so on, it goes to 0. Fine. Now we know what is vn, okay. U3 and u4 will be 0, okay. Now let us find what is vn here. Okay, so vn is uh, 2 to the power of n by 2, okay, and e to the power of x cos of x plus n pi by 2. Sorry, if I take this as n tan inverse of 1, okay, so this will be that. This further I can simplify as tan inverse is pi by 2, pi by 4. Tan inverse as inverse of 1 will be pi by 4. Fine. Let us try to evaluate this. So u v n, u v n. So this will be u v n Okay, so nc1 u1 vn minus 1 plus nc2 u2 vn minus 1. Fine. Let us try to put all those which we have said. So u being x square, u being x square, and this is Vn, which is 2 to the power of n by 2 e to the power of x cos x plus n pi by 4, because tan inverse of 1 is pi by 4. Now plus nc1 is n, u1 is 2, so you'll have e to the power of x, okay, e to the power of x into 2 to the power of we'll have that also. Let substitute that also here. Okay, so you'll have, this is 2x. Okay, you'll have 2x here, and 2 to the power of n minus 1 divided by 2 into e to the power of x cos of x plus, you have this as n minus 1 into pi by 4. So is it clear? This next term. Okay, let us move on to the next term, which you have this term. Okay, so that will be n into n minus 1 divided by 2 factorial. Fine. Now u2 is 2 into, we'll have now this as minus 2, if I consider n minus 2. So that is 2 to the power of n minus 2 divided by 2. Okay. So this is into e to the power of x cos of x plus, this will be n minus 2 divided by 4 into 5. Let me try to take common, which is there. Okay, and let us further try to simplify it. So x is equal to, now 2 to the power of n minus 2, okay, divided by 2 and into e to the power of x, which is common. Yeah, matrix also I'll explain if you want. Okay, in the next session I'll please tune in. I'll explain in the next session on matrix. Okay, matrix, I'll try to explain that also. Okay, thank you for listening. Let me complete this, and I'll, after this session I'll come back again and let us start with matrix. Okay, fine. Okay, so this will be 2x square. Okay, so there will be 2x square, and this is cos of x plus n by 4, and plus I'll have 2 to the power of this will be, if I try to simplify further, I get 3 by 2. okay, into nx, okay, cos of x plus n minus 1 pi by 4. Okay, and the last term, which is n into n minus 1 cos of x plus n minus 2 pi by 4. So this will be the solution. Okay, and please do come back, and I will try to solve some of the problems on matrices. Okay, which is very important, and which all steps, if you didn't understand, you just mark there, and so that I'll explain once again those problems more convenient way. Okay, thank you for listening, and please do come back for the matrices, okay, which will start within 15 minutes. Thank you.